revisited. The purpose of this lab was to build off of the charge tape experiment using a charge distribution model to determine if it's more accurate than the point charge model. Key concepts used in this lab were Newton's second law and Coulomb's law from Lab 1, and charge distributions. The main result was that tape charge from the charge distribution model was 6.25 times 10 to the negative 8th coulombs, which was larger than a point charge model's total charge. Fundamental principles used were Coulomb's law, which quantifies electric forces between charges, Newton's second law, which states that force is proportional to mass and acceleration. We can use this since because we're in static equilibrium, we can state that net force equals 0. Charge distribution states that charged objects can be approximated as a collection of point charges, which can be summed using intervals. Our procedure/setup was the same from Lab 1, where tape mass was 0.2 grams, tape length was 0.2 meters, tape width was 0.019 meters, and our tape was positively charged. Our system was tape B, while our surroundings were tape A and everything else. And the procedure was that tape A and B were charged, tape B was suspended, tape A was brought underneath tape B until it floated, and then the separation distance was measured. We can use the same analysis from last time. Instead, we use the charge distribution model instead of the point charge model. We state that gravitational force equals electric force, which is the charge of tape B times the electric field of a rod on its perpendicular axis. And using this, we can see that charge of tape B was 6.25 times 10 to the negative 8th coulombs. We can use a computational model to model this visually, and we can create an electric field function and a line of charge function first. Then we create tape models using the line of charge function, and then we calculate the electric force at each slice dq. As we can see, this creates a bunch of tiny green arrows which represent the electric force at each dq on tape B, which sums up to a net electric force represented by the white arrow, which is balanced by the yellow gravitational force. So the total charge using the charge distribution model was 6.25 times 10 to the negative 8th coulombs, while our point charge model gave us 5.41 times 10 to the negative 8th coulombs. The forces on the tape, determined by the computational model, was 1.76 times 10 to the negative 3rd newtons for the electric force, and for the gravitational force, 1.99 times 10 to the negative 3rd newtons. This gave us an 11.7% error because ideally our electric force should balance force of gravity, but this was not the case due to error sources. Some assumptions we made were that air resistance was ignored, tape was approximated as a line distribution of charge, not point charges like last time, that there were equal charges on both tapes, and that there was an even distribution of charge. Some possible error sources were that there were non-uniform charge distribution across the tape, charge loss to the environment, or imperfect charge modeling. So what if each tape was modeled as a point charge like in Lab 1? Well, the charge would be lower than if it was modeled as a line charge, as we can see with our determined values. So why do these estimates differ? Well, in the point charge model, all charge was concentrated as one point, meaning that the entire electric force acts upwards. Meanwhile, in the line charge model, our charge is distributed across the length of tape, meaning that each dq on tape A is further from each observation on tape B. Therefore, only the vertical component acts against gravity, and these two combined factors mean that we need a larger q to balance gravity. Most likely, our line charge model is more accurate as it better represents our tape geometry. Overall, we determined that our point charge model had this charge and our line charge model had this charge, and that our line charge had a larger q to compensate for geometry. Our results from the computational model were that there was about a 12% error difference in electric force and gravitational force, which was due to geometric simplifications and experimental uncertainty. Thank you for listening.